This segment is brought to you by GoToAssist. Hello and welcome to Hak5. My name is Darren Kitchen and this is your weekly dose of technology. I'm really excited because right now we're actually in Las Vegas for DEF CON 20, so be sure to check out the website, follow the social networks and see all the good stuff that we're getting into there. And I'm happy this week to be welcoming you guys to part 2 of our epic workshop on the Wi-Fis over at the San Francisco hackerspace Noisebridge. Hope you guys really enjoy this one and be sure to continue leaving us your feedback. We read almost every comment, except for that one that said burst. So the 6 modes of Wi-Fi. First one that we're going to talk about is master. This is the access point or base station mode. That is, you know, your little Linksys router, little blue guy with the antennas at home. That is running in what is known as master mode. And so, like I mentioned, all of these different devices have different capabilities. I'll SSH over into, or I think I already am, into my Pineapple here and do, oh, I lost my connection. Let's see. So if on this one I do an if config, I don't know what interface it is, WLAN 0. Well, regardless, we can come back to that one in a second when we talk about managed. Managed is the mode where most of you guys are running on your laptops and your smartphones right now. And that is just to say you are a client to a base station or an access point. So we're going to demo managed. And I have an access point over here ready to go. And quite simply, if I do iwconfig, not on this, hang on this, if I do iwconfig WLAN 2 and then mode managed, I've now set it into managed mode, and now all I have to do is set the ESS ID, or the name of the network, to whatever it is. In this case, it's Pineapple. And if I just check it now, I can see that mode is managed, and I am connected and associated to the Pineapple. And we're going to get into a lot more on association soon, but that's how, essentially, and the beautiful thing of it is, you guys don't have to, how many of you have typed all of that to connect to a wireless access point before? Well, that's the beauty of it, is you don't have to. So another mode is ad hoc or peer-to-peer. It's pretty cool. I'm going to skip this demo just because we've got more fun demos coming up, and we're a little bit further back than I expected to be right now. But basically, if you run that, what you're going to do is you're going to set your interface to be in an ad hoc mode. And so if somebody else were to run the same command, then they would join your mesh network, and then you'd have to static IP your guys selves, or somebody run a DHCP server or something. But regardless, if a bunch of people run this, they will create a mesh network or an ad hoc network called, not a mesh network, sorry, an ad hoc network called my ad hoc network. The other ones that I alluded to, mesh network or a mesh cloud or a mesh network, is kind of a planned ad hoc network. And the cool thing about those guys is that, for instance, if you have, like, say, a university or some large campus that you want to deploy Wi-Fi around, mesh networking can be really cool in that if, say, base station A is here and base station C is here, they'll communicate through base station B. And if for some reason it has a power failure or whatever and it goes down, then they'll reroute everything through what they are able to see. It's pretty cool the way that that technology works. And then there's another mode for repeater, which is kind of like a Wi-Fi extender. And then there's monitor mode, which is one of my favorites, RF-Mon. And monitor mode allows you to just see what is in the air. Okay, so we'll do a little demo of that. So, and I think I already brought it up. Let me see. I did. Okay, let me stop that and restart it. Okay. So in order to get my card into monitor mode, I use airmon ng, which is a part of the aircrack suite, and then I basically just say start and then the name of my interface. In this case, it's WLAN2, my alpha over here, and what it will do is it creates a virtual interface. In this case, it's named mon0. And now, if I do, for example, tshark, tac-I, the interface mon0, what we're looking at is everything that's going through the air. The beautiful thing about monitor mode is that you don't actually have to be associated or authenticated or somehow connected to an access point to see what's going on that access point. You could really just fire this up, and there's really cool, fun GUI tools. For example, DriftNet is one of them that allows, if your card is monitor mode, it just takes a look for any JPEGs that are going through the air on any wireless access point that's unencrypted, and goes ahead and displays those for you. That's a fun one to say run it at hackerspace on a projector.
I was told you can't do that, actually.
You were told you can't do that. Oh, okay. Well, so that's monitor mode. So modes and your NIC. I mentioned that all NICs aren't created equal, and depending on the chipset and some other factors, you may not be able to use all of those modes. Because mind you, most of us are only using managed. We're only using our laptops to connect to access points. We're not running access points from them, and we're probably not sniffing packets in monitor mode. But we can actually determine your device will support. So I'm going to go ahead and run airmon ng again. And what this will do is physical name of my adapter. In this case is PHY5. And so if I use IW, PHY5, and then say info, and there's a lot of stuff that comes out of this. I'm only interested in the modes. I'm going to grep 8 lines past modes. And you can see right here that the supported modes of my interface are only managed and monitor, because that's all this guy actually supports. It's kind of interesting, though, that this is one of the more popular Wi-Fi network cards for hacking, even though it only supports those 2 modes, because a lot of people have actually written software that emulates some of the other modes. It's not as fun to do that in user land, but regardless, this is only going to do managed and monitor. So I can't use it to, practically speaking, run an access point. So a word on transmit power, because like channels, transmit power, or TX power, is regulated by country. And so in the US, the maximum transmit power that you can use on Wi-Fi is 500 milliwatts, or half a watt, and that is 20 dBm. That's a huge rat hole onto lots of different ways in which you can, display different levels, but there's dBi and all these other ones. But essentially, take it to be 20 dBm is 500 milliwatts, and it's hard-coded into the kernel, these speed limits, right? Because the FCC wouldn't like it if everybody started using like 1 watt. But easier than hacking your kernel can sometimes be moving to a country with friendlier regulations. So we're going to go ahead and move to Bolivia. So if I do IW-reg get again, I can see that I'm again in country 00, and IW-reg set BO for Bolivia. I can now use IW-config. WLAN2 is my interface. TX power is what I'm interested in, and I'm going to set that to 30. I'll come over to another tab. Is that still running? Yeah. I'll come over to another tab and just do IW-config. Oops, still in the pineapple. And you can see here that my TX power is 20 dBm. If I try to do I already changed it, didn't I? Yeah, I already did. Okay, well, If I set this now, it's going to allow me to. And if I check now WLAN 2, you'll see that I am now running at 30 dBm, aka 1 watt of power. I'm going to set that back to 20. OK. And so that's moving to Bolivia, and it's illegal to do that in the US, so don't do that. Yes?
Is someone with a ham license allowed to do more?
Not that I know of. Yeah.
What if you're Japanese and Bolivian?
If you're in Bolivia and you're Japanese in Bolivia, awesome. Yeah, I'm not going to be the one to rock the boat on that issue. And the reason we choose Bolivia is actually because it's Bolivia and I want to say Belize, but I'm not positive on it. But I know for a fact Bolivia is one of the 2 countries who has the most lenient regulations. Allow you to use up to channel 13 and up to 1 watt. Japan is the only country that can use channel 14, and they don't allow 1 watt. So if you want to use all 14 channels and go to 1 watt of power, you're going to have to hack your kernel. It's actually really easy. It's a text file you change. It's so simple. OK. So there are 3 states of Wi-Fi. There is unauthenticated and unassociated. The next state from that is I'm so excited to welcome back a fond sponsor of ours, GoToAssist by Citrix. You guys know that working in IT is unpredictable and challenging. The firewall's going off at the same time that you're getting calls from management about the thing you told them not to click. Meanwhile, everyone's expecting you to get everything done without breaking what's already there. I know, I've been there, and that's why I am so excited about GoToAssist by Citrix. It helps you stay on top of it all. GoToAssist is software as a service and purpose-built, giving you more control over your IT world. You can use their world-class remote support to solve your users' problems quickly from anywhere. And GoToAssist Monitor brings customizable dashboards displaying performance of everything on your network. Plus, proactive alerting allows you to fix small issues before they become a huge headache. GoToAssist is so easy to use. You're going to have it up and running in minutes. It's by Citrix, a leader in IT. I've used GoToAssist in my sysadmin jobs before, and man, do I wish I had this latest version back then. Sign up for your special 30-day free trial today. Visit gotoassist.com and click the Try It Free button and use the promo code HAK5. Again, that's gotoassist.com with promo code HAK5. So there are 3 states of Wi-Fi. There is unauthenticated and unassociated. The next state from that is you're authenticated with the network, but you're not associated with the network. And then there's finally both authenticated and associated with the network. And I bring this up because there's ways to move a client from one state to another, and we're going to get into that in a bit, but just need to lay this groundwork here. Because what we're going to talk about now are Wi-Fi frames. Wi-Fi frames are just data packets, right? Little bits of information, and they're kind of just written in a way such that everything kind of works. They're typically come with a header of some sort that says who I am and where I'm going, so everybody in between knows where to pass me on, the router, gateway, everybody else. The ether type, you know, like what kind of protocol it is. Am I a UDP packet? Am I a TCP packet? Am I GRE? How much fun am I having, right? And then there will be a payload. And the payload is like whatever's actually inside there, usually pictures of kittens or whatever else have you on the internet. And then there will be a frame check sequence or a CRC or some sort of sanity at the end that says, hey, if I don't look like this, something went wrong. And so there are a lot of different types of Wi-Fi frames. There are control frames, and then again, there are data frames. And so let's go ahead and dive into some of those, because like I mentioned about the phone phreaking, it's the more that you actually learn about these protocols and the more that you realize the way in which they're put together, it'll become apparent where the weaknesses are, where the inherent trusts are, and how you can take advantage of those for mischievous fun. So control frames, we'll start with control frames, because just get these out of the way. Basically, these are the very kind of low level, like, hey, let's make sure we don't have massive traffic jams when we have this many people in the rooms with iPhones on, because we'll get to that later. But yes, could be a massive problem if all you guys were trying to connect to the same network and talk at the same time. So there are these things called a request to send, which is just this little blip where you're like, hey, can I talk? And the router, or the access point, or whatever you want to call it, the base station is going to send back, and this can happen in either direction, but it'll send back a clear to send, or a CTS frame, which will say, yeah, everything looks good. Nobody else is talking. Why don't we have a conversation? Everybody else shut up. You hear that? And so everybody does. And then when we're done speaking, we send an acknowledgement frame, or an ACK. And that's just to say, I heard what you said. Cool. You know, it all came out all right. So those are control frames. The real fun are these management frames. And there's 4 different types of them, and then subtypes within each. But basically, beacons are number 1. Beacons are awesome. I think I have a beacon frame. Yeah, there we go. So there's only one type of beacon frame. And they're used to advertise the network. If you've ever, in Windows, Linux, Mac, whatever, pulled up that drop-down that shows all of the networks in the area, most likely the way that it's working is it's listening for these beacon frames, which are being broadcast out to everyone, just advertising, hey, I'm a network. This is my SSID, or the name of my network. I'm ATT Wi-Fi. Come join me. And here are the channels that I support. Here are my capabilities. Here's the frequencies I'm using, all that fun stuff. And while not all access points may broadcast these, hint, hint, hidden ones, it doesn't mean that they're not there, you know, or that the network's not there. The broadcast frame isn't, but there could be a network there. Anyway, we're going to do a demo of beacon frames because they're really a fun thing to. So let's pull up our trusty Airmon NG. I've already started WLAN 2, so we're going to create a new file here. Where am I? I'm in root. Let me see if I have one. OK. All right. Let's go ahead and create a new file. We're going to call it ssidlist.txt. And so everybody just start naming out nouns and verbs and anything else.
Linksys.
Duck, neck beer, pineapple, hornet.
Noisebridge.
Well, not ones that exist. Come up with anything else. Come on. We're going to broadcast this all the way to Mission Street.
Kiwi. Apartment 204.
SFPD Band 2.
OK.
Police Band.
FBI van.
FBI van. I like that.
Immigration.
No.
Free weed.
Free weed?
Weave.
I heard free weed. OK. So we've created our file. And now we use an awesome new tool. Do I have a frame for it? No. We're going to use an awesome tool called MDK3. Who can guess what that stands for? Trivia. It stands for Murder, Death, Kill 3. I don't name this stuff. And so what we do is MDK3. And where are my options? My interface. We already set up our monitor mode interface. And B for beacon frame. And then tac F, our list of, what do we call it? SSID list.txt. And now, if you turn on your phones, open your laptops, refresh your network settings, take a look for nearby access points, you're going to see that kitten and free candy and FBI van and free weed and all of those else are now here. And there's a reason that I do this. All right, you guys see them?
Yes.
All right, cool. I'm going to go ahead and stop this. You can really have a lot of fun with this if you do like 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0. Anyway. Sort of mischief. So we're going to go ahead and actually analyze some frames now because that's how geeky we're getting. And we're going to fire up Wireshark, which is an awesome packet analyzer or frame analyzer, however you want to call it, that's going to allow us to just go ahead and drill into those and actually take a look at what's going ahead and happening in these types of management frames. So let me just go ahead and fire up Wireshark here. And I'm going to go ahead and listen on Mon0. And so like before when I used T-Shark on Mon0, we're now using a cool graphical tool called Wireshark. And what we're looking at is everything that is going through the air right now, well, that it's able to see. There's channel hopping involved. I'm not on all 14 channels at once. You'd have to build a rig with 14 Wi-Fi adapters to do that. Not like we've ever done that. Or put it in a Hello Kitty backpack and you'd Shannon strut down, what is it, second in mission with that? Yeah, anyway. So, where are we? All right, so what we're going to do is actually look for a certain type of management frame. It's going to be wlan.fc subtype.